Hello students, hope you are doing well. Welcome to my channel where we nurture and learn mathematics beyond boundaries. In today's video, we are going to cover Poisson distribution as part of the probability unit for class 12 CBSE applied maths. The questions have been picked up from the CBSE handbook, ML Agarwal, PYQs and the CBSE sample papers. To get a comprehensive coverage of all the kinds of questions for Poisson distribution, watch the video till the end and to understand the common mistakes that can be avoided to score well in probability. So let's get started with Poisson distribution. The last two videos have already covered probability distribution table and the binomial distribution. The links for the videos are given in the description below. Go back and watch the two videos before you proceed with Poisson distribution, because Poisson distribution is same as binomial distribution. It is an extension to binomial distribution. So let's get started with Poisson distribution. First, we need to understand what is binomial distribution. When any trial has two outcomes, success and failure, and the probability of success or failure across trials remains same, also if the number of trials is known in advance, then it is a case of binomial distribution. Now, as we have seen, binomial distribution gives you lots of terms. There are lots of terms in the binomial expansion. So if n becomes very large, it becomes difficult to solve a question related to binomial distribution using the binomial formula. So Poisson distribution comes to rescue, and it is an approximation for binomial distribution when we have a large value of n and a very small value of the probability. So if n tends to infinity and p tends to 0, np becomes infinite, and this is denoted by the Greek letter lambda. Now we are not getting into the derivation of the formula for Poisson distribution. The formula is P of r is e raised to power minus lambda, lambda to the power r upon r factorial, where r varies from 0, 1, 2 till infinity. Now how do we find the mean and variance of Poisson distribution? Both mean and variance for Poisson distribution are equal to lambda, which is product of n and p, and the standard deviation is square root of lambda. Now there is also a recurrence relation. As we have seen in binomial distribution, there is a pattern that gets followed throughout the distribution, throughout the expansion of binomial theorem. So here that pattern has been used to create this recurrence relation, where we have P of r plus 1 is equal to lambda upon r plus 1 into PR. Don't get bothered by the notations, whether it is the Poisson formula or the recurrence relation. As we solve questions, you will get comfortable with both these formulas and how to use them. So in case you know the value of P0, you can easily find the value of P1 by just multiplying P0 by lambda upon 1. So this is what we get from the recurrence relation. And if you want P2 also, then lambda by 2 into P1. So you put the value of P1, you get the value of P2 also. So here you just need to put different values of R and keep on calculating successive values of probability in case you need to calculate more than 2 or 3 values of probability. Now recurrence relation formula should be used only if it is specified in the question, but otherwise there are other ways also to make your calculations easier, as we will see in the questions that we solve. So let's get started with the first question. If a standard deviation of Poisson variable x is root 3, then find probability of x greater than 0. So standard deviation is given to you as root 3. That means sigma is square root 3. Squaring both sides, we get the variance as 3. Now for Poisson distribution, variance is same as lambda. So 3 is the value of lambda that we have, and we need to calculate probability of x greater than 0. So whenever we need to calculate probability of a random variable greater than some value, look on the other side. What is there less than that value? For example, so for in this case, you need to find 1 minus probability of x being equal to 0. That will give you the value of probability of x being more than 0. So let's find that. Formula for Poisson distribution, e raised to power minus lambda, lambda to the power r upon r factorial. Make it a point to write the formula so that you don't make mistakes putting the values. So now 1 minus e raised to power minus lambda is 3 here, e raised to power minus 3, 3 to the power 0 upon 0 factorial. So this becomes 1 minus 3 to the power 0 upon 0 factorial is 1. Put the value of e raised to power minus 3, that is 0.05. So that gives you a value of 0.95. So this is your answer. Let's move to the next question. If x is a Poisson variate such that probability of x is 0, Probability of x as 0 and probability of x as 1 both are equal and both are equal to alpha. Show that alpha is equal to e raised to power minus 1. Now let's put the formula for px equals 0. So it is e raised to power minus lambda, lambda to the power 0 upon 0 factorial. And this comes out to be e raised to power minus lambda. Next, probability of x equal to 1 will be e raised to power minus lambda, lambda to the power 1 upon 1 factorial, and this comes out to be e raised to power minus lambda into lambda. Now as per the question, both are equal. If both are equal, that means e raised to power minus lambda is same as lambda into e raised to power minus lambda. This gets cancelled and the value of lambda comes out to be 1. And both are also equal to alpha. So let's equate any of these distributions, any of these probabilities to alpha. So that means lambda into e raised to power minus lambda is equal to alpha. Putting lambda as 1, you get e raised to power minus 1 is equal to alpha, and this is what you need to prove. Hence proved. Done? Easy? Great. So let's move to the next question. Suppose 2% of the items made by a factory are defective. Find the probability there are 3 defective items in a sample of 100 items selected at random. Now, how many items are defective? 2%. So that means the value of P is 2 by 100. Sample size is 100. That means N is 100. So first we need to calculate lambda. Lambda is N into P. That means 100 into 2 by 100, and that comes out to be 2. Find the probability that there are 3 defects in a sample. So that means you need to find the probability when x is equal to 3. So this is e raised to power minus lambda, lambda to the power r upon r factorial. Let's put the values. Lambda is 2, e raised to power minus 2, and then 2 to the power 3 upon 3 factorial. So the given value e raised to power minus 2 also gives you a hint that the value of lambda here is 2. So just put the value of this, it comes out to be 0.135 into 2 cube is 8 upon 3 factorial is 6. And when you solve this, this comes out to be 0.18. So the final answer is 0.18. Easy? Yes. So let's move to the next question. The mortality rate for a certain disease is 0.007. Using Poisson distribution, calculate the probability for 2 deaths in a group of 400 people. So that means you are given P as 0.007 and group of 400 people means N is 400. So the value of lambda is going to be the product of these two values. 0.007 into 400, 7 4s are 28, and if you adjust the decimal points, you get 2.8. E raised to power minus 2.8 also suggests you that lambda is 2.8. Now we need to find the probability for x being equal to 2. That means first write the formula so that you don't make mistakes, and then put the values. E raised to power minus 2.8, 2.8 to the power 2 upon 2 factorial. So let's put the value given 0.0608 into 2.8 into 2.8 upon 2. And when you solve this, you get a value of 0.23. So that becomes your answer. Easy? Great. So till now we have just used the formula directly. A car hire firm has 2 cars which it hires out day by day. The number of demands for cars on each day is distributed as a Poisson distribution with mean as 1.5. So you are directly given the mean here. Calculate the probabilities of days on which neither car is used. Neither car is used means there is no request coming in. So that means you need to find the probability of x being equal to 0. Nothing is being used. And the second case it says, and the probability of the days on which some demand is refused. When will the demand be refused? When both the cars are used. So that means when you are getting requests more than 2, probability of x being greater than 2. Right? So let's look at what is lambda. First thing you should always check is what is lambda. And the given value in the question also gives you a hint what is lambda. So be careful. You know what is lambda. Now let's find probability of x being equal to 0, e raised to power minus lambda, lambda to the power r upon r factorial. So that comes out to be e raised to power minus 1.5 to the power 0 upon 0 factorial. And you just have this value 0.2231. So this is the required probability of neither car being used. Now let's find the probability for x being greater than 2. Again, it is a case where you need to find the probability of x being greater than a certain value. So look on the other side. That means the value is lesser than 2. So let's do that. So this is going to be 1 minus probability of 0 plus probability of 1 plus probability of 2. So let's put the values as per the formula. It is e raised to power minus 1.5, 1.5 to the power 0 upon 0 factorial plus e raised to power minus 1.5, 1.5 to the power 1 upon 1 factorial plus e raised to power minus 1.5, 1.5 to the power 2 upon 2 factorial. Now you must be wondering how to solve this. This looks very cryptic. No, it's very easy. Take e raised to power minus 1.5 common out. What is left out is just 1 here. Here you have 1.5 and here you have 1.5 square upon 2. So let's solve it further. 1 minus value of e raised to power minus 1.5 is 0.2231. And in the bracket you have 1 plus 1.5. So you can do this calculation. 1 plus 1.5 is 2.5. 2.5 plus 1.5 square upon 2. And when you calculate all this, finally what do you get? So this is 2.5 plus 1.5 square by 2. And on doing all these calculations, the final answer comes out to be 0.1913. It's okay. We can do so much calculations. We are used to. Okay, next question. Suppose that x has a Poisson distribution. If x probability of x being equal to 2 is 2/3 of the probability of x equal to 1, evaluate probability of x is equal to 0. Now, first let's find what is the probability of x equal to 2. So, e raised to power minus lambda, lambda to the power 2 upon 2 factorial. And what is the probability of x being equal to 1? So, this is e raised to power minus lambda, lambda to the power 1 upon 1 factorial. Let's use this condition and create an equation. So e raised to power minus lambda, lambda square upon 2 is equal to 2/3 of e raised to power minus lambda into lambda. So this gets cancelled and one of the lambda also gets cancelled. So the value of lambda is 2 into 2, 4 by 3. Now we need to find the value of probability of x being equal to 0. So let's put the formula again. E raised to power minus 4 by 3 lambda to the power r is 0 in this case, so you don't even need to write, and because you are not given any value of e raised to power minus 4 by 3 in the question, so it's okay to leave the answer here as it is. E raised to power minus 4 by 3 becomes your answer. Okay, let's move to the next question. If the variance of the Poisson distribution is to find the probabilities for r is equal to 1, 2, 3, 4, 5 using the recurrence relation of Poisson distribution. Now here the question says you have to use recurrence relation. What was the recurrence relation? It was probability of r plus 1 equals lambda upon r plus 1 into probability of r. So let's start with r being equal to 1. And before that, we should understand what is the value of lambda. If the variance is given to you as 2, variance is same as lambda, so that means the value of lambda here is 2. So let's find P1. So P1 is going to be e raised to power minus lambda, lambda to the power 1 upon 1 factorial. Lambda is 2 here, so e raised to power minus 2 into lambda is 2. So e raised to power minus 2 into 2. So that means twice of the value given to you, 2 into 0.1353, and that comes out to be 0.2706. So this is the value of P1. Let's find the value of P2 using the recurrence relation. It is going to be lambda upon 2 into P1. What is lambda? 2. So 2 by 2 into what is the value of P1? It is 0.2706. So that comes out to be 0.2706 only. Same value here. Right? Next, let's find the value of P3. So P3 is lambda by 3 into P2. So this is 2/3 of the probability of 2. 0.2706, and when you calculate this, you get a value of 0.1804. Next, probability of 4 is going to be lambda upon 4 into P3. Lambda is 2 by 4 into P3, that is 0.1804. 2 by 4 becomes half. So half of this is 0.0902. Next, P5. P5 is going to be lambda upon 5 into P4. Lambda is 2, so it is 2 by 5 into 0.0902. And when you calculate this, you get a value of 0.0361. So you found all the values using the recurrence relation. Now, because the question said you have to use recurrence relation, so you use it. But in other questions, just avoid using recurrence relation. Next question. On doing proofreading of a book, on an average, 4 errors in 10 pages were detected. Using Poisson's distribution, find the probability of no error or 1 error on a page randomly selected from 1000 pages of the first printed edition of the book. Now here, you need to find the probability of x being equal to 0 and x being equal to 1. But what is given? On an average, 4 errors in 10 pages. That means lambda is 4 upon 10. And you need to find all these probabilities for a single page. So that is into 1, and that gives you the value of lambda as 0.4 only. So this is basically n and this is p. Product of these two gives you the value of lambda. Now let's find the probability of x being equal to 0. So it is e raised to power minus lambda, lambda to the power r upon r factorial. E raised to power minus 0.4. 0.4 to the power 0 upon 0 factorial. So we are given the value of e raised to power minus 4. This comes out to be 0.6703. So this is the probability of no error on a page that is randomly selected. Now what is the probability of x being equal to 1 error? So e raised to power minus lambda, lambda to the power 1 upon 1 factorial. And what is lambda? 0.4. So e raised to power minus 0.4. 0.4 to the power 1 upon 1 factorial. And when we just put the value given, so it comes out to be, the product of these two is 0.26812. So it is 0.26812. So this is the probability. Now, in case you also need to find the number of pages that could have have 0 errors or 1 errors from a book of 1000 pages, you just need to multiply these values by 1000 and you will get the number of pages. So now, if you need number of pages also, always remember probability is always less than 1. Probability is always less than 1. It can never be greater than 1. So if you need to find the number of pages with 0 errors, pages with 0 errors means, that means you just multiply the probability for 0 errors by 1000. So that means there are approximately 670 pages that would have no error. Similarly, the number of pages with 1 error. So it is going to be 0.26812 multiplied by 1000, and this gives you an approximate value of 268 pages. So there are going to be approximately 268 pages with 1 error and 670 pages with no error. Fine. So let's move to the next question. A river near a small town floods and overflows twice in every 10 years on an average. Assuming that the Poisson distribution is appropriate, what is the mean expectation? So you need to find the mean expectation. Also calculate the probability of 3 or less. So it is 3 or less overflows and floods in a 10-year interval. So let's first find what is lambda. Even though this gives you a hint that lambda is going to be 2, but you need to write and show that it is 2. So lambda is n into p. What is n here? 10-year interval. So focus on the intended interval, that is 10 here, and the average given to you is also for 10 years, twice in 10 years. That means 2 upon 10 multiplied by this value of 10. It gives you a value of lambda as 2, which is also evident from here. What value is given to you in the question? For example, it was 5-year interval here. what would have been the value of lambda? Then lambda would have been 2 upon 10 into 5. 2 5s are 10, 5 into 5, and it comes out to be 1. Right? So you need to calculate the value of lambda very carefully as per the intended interval and the rate at which the information is given to you. Now let's find the probability for x being 3 or less. So we need 3 or less overflows. That means probability of x being less than equal to 3. So that comes out to be probability of 0 plus probability of 1 plus probability of 2 plus probability of 3. Right? So let's find all these using the Poisson distribution formula, which is e raised to power minus lambda, lambda to the power r upon r factorial. Please do write this formula so that you don't make any mistakes. Lambda is 2 here. So this comes out to be e raised to power minus 2. 2 to the power 0 upon 0 factorial plus e raised to power minus 2, 2 to the power 1 upon 1 factorial plus e raised to power minus 2, 2 square upon 2 factorial plus e raised to power minus 2, 2 cube upon 3 factorial. From all these, take e raised to power minus 2 common out, and what we are left out with is 1 plus 2 square is 4, 4 by 2 plus 2 cube is 8, 8 by 3 factorial is 6. So when we solve all these values, when we add up all these values in the bracket, we get 19 by 3. Let's put the value of e raised to power minus 2, 0.13534 into 19 by 3, and after doing the calculation you get your answer as 0.8571. Understood? Great. So let's move to the next question. It is known that 3% of plastic buckets in a factory are defective. Using Poisson distribution on a sample of 100 buckets, find the probability of 0 defective buckets and at most 1 defective bucket. Okay, so you are given a sample of 100 buckets and 3% of the factory buckets in the factory are defective. So this is the value of P. P is 3%, N is 100. So that means the value of lambda is N into P. That comes out to be 3. You are also given e raised to power minus 3. That helps you. Now you need to find the probability of 0 defective buckets. X equals 0. So e raised to power minus 3, 3 to the power 0 upon 0 factorial. So you just put the value that is given to you, that is 0.049. Next we need to find at most 1 bucket is defective. So at most means probability of x being less than equal to 1. At most 1 is defected. So it could be either 0 defected or just 1 defected. So that means this is equal to probability of 0 plus probability of 1. Let's put the formula e raised to power minus 3, 3 to the power 0 upon 0 factorial plus e raised to power minus 3, 3 to the power 1 upon 1 factorial. Take e raised to power minus 3 common out. You have 1 plus 3. So that becomes 4 times the value that is given to you in the question, that is 0.049. And if you calculate this, it comes out to be 0.196. So this is the required probability. Always highlight your answer for all the parts. So there were 2 parts and we've done that. Okay, so let's move to the next question. For a Poisson distribution model, if arrival rate of passengers at an airport is recorded as 30 per hour on a given day, find the expected number of arrivals in first 10 minutes of an hour. Now first is, in the question you are given 30 arrivals per hour. You are given the rate at which something is happening, and the first step is always to find the value of lambda as per the intended interval. So in the first case it is 10 minutes, here also 10 minutes, here also 10 minutes, and in the last part it is something different. So let's look at all these cases one by one. Let's start with the first one. So it says in an interval of 10 minutes, what is the expected number of arrivals? So the Poisson distribution, the rate is 30 per hour. That means P is 30 upon 60, 60 minutes. 1 hour is 60 minutes. So this comes out to be 1 by 2. And what is N? N is 10 minutes for part A. That means the value of lambda is half of 10, and this comes out to be 5. And you have a hint here also that it should be 5. But how it is 5, you have to show the working. Now we need to find what is the expected number of arrivals in the first 10 minutes. So that means the expected number of arrivals in the first 10 minutes is 5. You don't need to find any probability, just that the expected number of arrivals. Expected number of arrivals means expectation. Expectation means mean. And in case of Poisson distribution, mean is lambda. So that means the expected number of arrivals is 5. Please write the answer statement for every part. Expected number of arrivals in first 10 minutes is 5. Because as per the CBSE marking scheme, you will lose half mark even for not just writing this answer statement. So write the answer statement for every part. Next, B part, the probability of exactly 4 arrivals in first 10 minutes of an hour. So for 10 minutes, we already know the value of lambda is 5. So let's find the probability of x being equal to exactly 4. So that means e raised to power minus 5. And then we have 5 to the power 4 upon 4 factorial. Let's put the value of e raised to power minus 5, 0.0067 into 5 into 5 into 5 into 5 upon 4 factorial is 4 into 3 into 2. And when you do all this calculation, it comes out to be 0.174. Let's look at part C. The probability of 4 or fewer arrivals in the first 10 minutes of an hour. 4 or less than 4. That means you need to find the probability of x being less than equal to 4. So that comes out to be what? Probability of 0 plus probability of 1 plus probability of 2 plus probability of 3 plus probability of 4. You must be wondering so much of calculation. But it's easy because always make it a habit to take out e raised to power minus lambda common out and then solve it. So it's easy, not difficult. So it is e raised to power minus 5 to the power 0 upon 0 factorial plus e raised to power minus 5 into 5 to the power 1 upon 1 factorial plus e raised to power minus 5 square upon 2 factorial plus e raised to power minus 5 cube upon 3 factorial plus e raised to power minus 5 to the power 4 upon 4 factorial. Take e raised to power minus 5 common out. So we have 1 plus 5 plus 5 square is 25, 25 by 2, 5 cube is 125 upon 3 factorial is 6 and then 25 square is 625 upon 4 factorial is 24. So e raised to power minus 5, let's put the value. It is 0.0067 multiplied by the sum of all these values will come out to be 1569 by 24, and on doing this final calculation, the probability is 0.438. Done? Great. So let's now look at the last part, which is the most important part here. The probability of 10 or more arrivals in an hour, given that there are 8 arrivals in the first 10 minutes. So there are 8 arrivals in the first 10 minutes out of needed 10. So that means in the next 50 minutes, you just need 2 arrivals. So you need to find the probability of x being, so you need exactly just 2 arrivals or maybe even more than that. So it is going to be probability of x being greater than equal to 2. How do we find that? Whenever we have a greater than sign here, look on the other side. 1 minus probability of 0 and probability of 1. So if you take this out from 1, you get the probability of 2 or more arrivals in the next 50 minutes. Now before we calculate this, we need to adjust the value of lambda as per the intended duration, which is now 50 minutes, and we need 2 arrivals in these 50 minutes. So what was the rate at which people were arriving? It was 1 by 2. That means 1 by 2 multiplied by n, which is 50 now, it comes out to be 25. So value of lambda is 25 now. So let's do the calculation. 1 minus e raised to power minus 25, 25 to the power 0 upon 0 factorial plus e raised to power minus 25, 25 to the power 1 upon 1 factorial. Take e raised to power minus 25 common out. You are left out with 1 plus 25. Now you are not given the value of e raised to power minus 25 in the question. So let it be 1 minus 26 into e raised to power minus 25. This is your answer. In case it was a smaller value. Now, if you are given the value of e raised to power minus 5, you can calculate the value of e raised to power minus 25 also like this. But if it was, square or cube, you could have still calculated because it is a higher power, 5/5 power of e raised to power minus 5. So you can leave your answer here like this. It's perfectly okay. When you are not given the values of the exponent part, you can leave it here. Okay, so let's move to the next question. Phone calls arrive at the rate of 48 per hour at the reservation desk for Indian Airlines. Calculate the probability of receiving 3 calls in 5 minutes interval. So here the rate at which something is happening is given to you. That means P is 48 calls per hour, 48 upon 60. 12 4s are 48, 12 5s are 60. That means 4 by 5. Now the intended interval is 5 minutes. So that means the value of lambda is going to be 4 by 5 into 5. That comes out to be 4. Hint here. So you need to find the probability of receiving 3 calls in the first part. So that means probability of x being equal to 3 e raised to power minus lambda to the power r upon r factorial. So this comes out to be, put the value for e raised to power minus 4, it is 0.018 into 4 cube is 64 and then 3 factorial is 6. Do this calculation and you have 0.192 as the probability. Second part, compute the probability of receiving exactly 10 calls in 15 minutes. Now here the intended interval has changed. Earlier it was for 5 minutes, now you need to find for 15 minutes. So adjust the value of lambda. What is lambda now? P is 4 by 5 into 15 minutes. 5 3s are 15, 4 3s are 12. That means the value of lambda now is 12. You need to find the probability of exactly 10 calls. So that means probability of x being equal to 10. So e raised to power minus 12 and 12 to the power 10 upon 10 factorial. Now in this question you are not given the value of e raised to power minus 12. So it's okay, you can leave it in this form. Otherwise also it's very difficult to find 12 to the power 10 or maybe 10 factorial also. So just leave it in this form. You are not even given the value. So it's okay. Third part. Suppose no calls are currently on hold. If the agent takes 5 minutes to complete the call, how many do you expect to be waiting by that time? What is the probability that none will be waiting? So none will be waiting means you need to find the probability for x being equal to 0. Now before that you need to understand what is the value of lambda here. Suppose no calls are currently on hold and the agent takes 5 minutes to complete the call. So in a duration of 5 minutes, no calls are on hold. So you need to find that there are no incoming calls in this 5 minutes duration. That means probability of x being equal to 0 in this duration. Now for n as 5, we need to first find the value of lambda. So the first step should always be to find the correct value of lambda. Lambda is going to be 4 by 5. 4 by 5 into 5 and that comes out to be 4. So probability for x being equal to 0 is going to be e raised to power minus 4, 4 to the power 0 upon 0 factorial and you are given the value of e raised to power minus 4 which is 0.018. So this is the probability of no waiting call in this duration of 5 minutes. Now what is the last part? The last part says if no calls are currently being processed, nothing. What is the probability that the agent can take 3 minutes for personal time without being interrupted by a call? So you need to find that in a duration of 3 minutes, there are no incoming calls. Only then he'll get 3 minutes of personal time, right? So that means you need to first adjust the value of lambda for 3 minutes interval. So value of lambda for the fourth part is going to be 4 by 5 into 3. Four by 5 into 3 and that comes out to be 12 by 5. 12 by 5 is 5 2s are 10, 5 4s are 2.4. We are anyhow given the value of e raised to power minus 2.4. So that confirms that the value of lambda is e raised to is 2.4. So now we need to find that there are no calls for these 3 minutes. That means x is equal to 0. So e raised to power minus 2.4 to the power 0 upon 0 factorial, and that comes out to be whatever value is given to you, that is 0.091. Done? So that means these people are so busy, the probability of no call for even 3 minutes is so low, almost 0. Oh, he cannot get 3 minutes of personal time. Okay, next question. A traffic engineer records the number of bicycle riders that use a particular cycle track. He records that on an average 3.2, average is 3.2 riders use the track every hour. So it is every hour. Given that the number of bicycles that use the cycle track follows a Poisson distribution, what is the probability that 2 or less bicycle riders will use the track within an hour? So now what is lambda? Let's first find what is lambda. Because here also it is an hour, and here also every hour. So we don't need to worry about the intended interval or anything else. So we can straight away write lambda is 3.2. Here you should have been given the value of e raised to power minus 3.2, which is 0.041. So this is given to you. So this also confirms that lambda is straight away 3.2. Now you need to find the probability of 2 or less bicycle riders using the track within an hour. So that means you need to find probability of 0 plus probability of 1 plus probability of 2. Right? So probability of x being less than equal to 2 is this. So let's put the formula. E raised to power minus lambda, lambda to the power r upon r factorial. Again, for all these three probabilities, let's just put the values. Take e raised to power minus 3.2 out. So take e raised to power minus 3.2 common out, and you are left out with what? 1 plus 3.2 plus 3.2 square upon 2. Put the value of e raised to power minus 3.2, which is 0.041, and then when you add these, it comes out to be 9.32. So the final answer is 0.382. Okay, the next part is 3 or more bicycle riders will approach the intersection within an hour. So 3 or more riders within an hour, that means you need to find the probability for x being greater than equal to 3. Now again you are given something greater than. Whenever you have greater than, what do? Look at the other side and find what is less than and take that away from 1. So let's do that. So this is equal to 1 minus probability of 0, or maybe we can just straight away write probability of less than equal to 2, because we have already calculated that in the first part. So always be smart and try to reuse whatever you can. So 1 minus probability of x being less than equal to 2, we can straight away use that here rather than doing it 0 plus 1 plus 2 again. So here the value will be 1 minus 0.382, and this will be equal to 0.618. So this is your answer. Right? Now the question also says find the mean expectation and variance for the random variable x. So mean expectation and variance both are equal to lambda, and that is equal to 3.2 in this question. So this is the mean also and the variance also. Clear? Okay, let's move to the next one. So we just have 2-3 more questions, don't worry. So let's do it. It is known that 3% of plastic buckets of a factory produced in a factory are defective. Using Poisson distribution from a sample of 100 buckets, find the probability of 0 defective buckets. So you are given P is 3 by 100, N is 100, 0 defective buckets. That means you need to find P of x equal to 0. So e raised to power, what is lambda? Lambda is 3 by 100 into 100, which is 3. The hint is also there. So e raised to power minus 3, 3 to the power 0 upon 0 factorial. Put the value 0.049. So this is the probability for first part. Next one is at most one bucket is defective. For the second part, you need to find at most one. At most one means probability of x being less than equal to 1. So this is probability of 0 plus probability of 1. So let's put the formula. This is e raised to power minus 3, e raised to power minus 3 into 3 to the power 1 upon 1 factorial. Take e raised to power minus 3 common out. So it comes out to be 1 plus 3, which is 4. So 4 into 0.049, and this comes out to be 0.196. Okay, let's move to the next question. A factory produces bulbs of which 6% are defective bulbs in a large bulk of bulbs. Based on this information, answer the following. Find the probability. 6% are defective, rate is given. Find the probability that a sample of 100 bulbs. So N is 100, P is 6%. None of the bulbs is defective. Iska probability nikalna hai. So first let's find lambda. Lambda is N into P, 100 into 6 by 100. That comes out to be 6. So you are anyways given e raised to power minus 6. Probability for none of the bulbs being defective, that means probability of x being equal to 0. So it is e raised to power minus 6, and you just straight away write the value. 0.0024 is the answer for the first part. Second, find the probability that the sample of 100 bulbs has exactly 2 defective bulbs. Exactly 2 defective. So that means you need to find probability of x being equal to 2. So it is e raised to power minus 6, 6 to the power 2 upon 2 factorial, 0.0024, 6 square is 36 upon 2, and on calculating this comes out to be 0.432. Third part, find the probability that the sample of 100 bulbs will include not more than one defective bulb. So you need to find the probability of getting not more than one defective. Not more than one defective means either 0 or 1, but not more than 1. So probability of not more than 1 means probability of 0 or and the probability of 1. You need to find this. So let's just put the values again. E raised to power minus 6, 6 to the power 0 upon 0 factorial, plus e raised to power minus 6, 6 to the power 1 upon 1 factorial. Take e raised to power minus 6 common out. It comes out to be 1 plus 6. That means 7 times 0.0024, and this comes out to be 0.0168. Next, the last part of this question, find the mean and variance of the distribution of number of defective bulbs in a sample of 100 bulbs. Sample is still 100, so you don't need to change lambda. Now because mean and variance of Poisson distribution is same as lambda, so that means the mean and variance both are equal to lambda, and that is equal to 6 in this question. Easy? Great. So let's move to the next question. A small town experiences on an average 2 power outages per month. Assuming that the number of power outages follows a Poisson distribution, find the probability that in a given month there will be exactly 3 power outages, given that there will be at least one power outage. Now this is a very different question and very important one. Please understand what you need to find out and what is given. You are given on an average there are 2 power outages, that means lambda is 2. Hint is here. What you need to find out, look at it. You are being asked to find out there are exactly 3 power outages, given that at least one power outage is there. So P of at least 1. So this is what you need to find out. Probability of x being equal to 3, given that x is greater than equal to 1. So if you remember, this is called conditional probability, and we have done conditional probability in grade 11. So how do we calculate conditional probability? How do we find out? In the numerator you have intersection of these two, and in the denominator you have probability of the condition that has already taken place. So this is going to be equal to probability of x being equal to 3 intersection probability of x greater than equal to 1 upon probability of x being greater than equal to 1. We have done this conditional probability in grade 11, so that gets applied here. Now, if you think of x being equal to 3 and greater than equal to 1 and their intersection, so intersection is going to be equal to probability of x being equal to 3 upon probability of x being equal greater than equal to 1. So this is what we need to calculate now. So let's find the individual values first. Probability of x being equal to 3 is going to be e raised to power minus 2 cube upon 3 factorial. Put the value 0.14, 2 cube is 8, 3 factorial is 6. Calculate this and you get 0.19. Next, find the probability of x greater than equal to 1. Now, because it is greater than sign, that means you need to look on the other side and take away from 1. So, what do we need to take away from 1? 1 minus probability of 0. Greater than equal to means just take away 0. So, this becomes 1 minus e raised to power minus 2, 2 to the power 0 upon 0 factorial. That means 1 minus 0.14 and this becomes 0.86. Now, what is the final probability that we needed? It is the quotient of these two. So, you have 0.19 divided by 0.86. So, the final probability comes out to be 0.22. So, this question was a little different. So, be careful when you have conditions like this, questions like this for conditional probability. Next, last question. A certain type of electronic component fails at a rate of 2 failures per 1000 hours of operation. So, the rate of failure is 2 out of 1000. Assuming that the failures follow Poisson distribution, find the probability in a 5000 hour operation. This is the intended interval in a 5000 hour operation. So, the value of lambda comes out to be n is 5000 here and the value of lambda product of these two will come out to be 10. So, lambda is 10, the product of n and p. There will be more than one failure. So, you need to find the probability that there will be more than one failure. More than one means you need to look on the other side, more than one failure. And you take away from 1. That means you need to subtract probability of 0 and 1 from 1. So, let's put the formula e raised to power minus 10, 10 to the power 0 upon 0 factorial plus e raised to power minus 10, 10 to the power 1 upon 1 factorial. And take e raised to power minus 10 common out, it becomes 1 plus 10. That means 1 minus 11 into e raised to power minus 10, the value is given to you. 4.54 into 10 raised to power minus 5. So, just do this multiplication. It will come out to be 1 minus 0.0004994 and the final answer is 0.995. Approximately this is your final answer in this case. Right? So, now what are the common mistakes that children make while doing questions related to probability, that is Poisson distribution? So, the first thing is you need to understand that probability and lambda are two different things. They are different. Probability is something that is likelihood of an event and lambda is the product of n into p. Sample space multiplied by probability is lambda. So, probability is different from what is given to you. If the rate of something is given to you, read the question very carefully and understand what is given, whether lambda or probability is given. Probability is between 0 and 1, whereas lambda can have a value greater than 1. As we have seen in so many questions, probability is always between 0 and 1, but lambda can have a value of 10 also, 2.4 also, 20 also. So, it can have a value of greater than 1. So, that also helps you to differentiate between the values of probability and lambda. Adjust lambda as per the interval of interest. So, all we have seen in so many examples, intended interval is very important. You multiply the rate at which some event is happening with the intended interval to get the value of lambda for every subpart that you need to solve for your question. So the given value gives you a hint what is lambda. Lambda is average rate into time period of the interest. So for every part, if the sample size is different, if the intended interval is different, always find all the values of lambda and then solve. In Poisson, we have x is equal to r, not x less than equal to r. So that means whenever you need to find x less than equal to r, you need to find the cumulative probabilities of 0, x being equal to 0, 1, 2, 3 till r. And in case you need to find the probability of x being greater than r, in that case you look on the other side. That means 1 minus probability of x being less than equal to r. Right? So these are the common mistakes that children make while solving questions in Poisson distribution. Avoid these mistakes to make sure that you don't lose marks for any of these. If you really want to master probability, you need to practice lots of exam focused questions. On my website Boundless Maths, all the 8 units have been comprehensively covered with all the MCQs, assertion, reason, short and long answer, case studies, all with their solutions as per the CBSE syllabus and the board exam pattern. Also, you can find CBSE sample papers and PYQs for practice. Additionally, you can also get the class 12 applied maths formula deck that covers every formula of every unit and even the important theory points that are important from MCQ perspective. So get the copy of your class 12 applied maths formula card and keep practicing, because the secret to success is always to understand and practice as much as you can as per the pattern of the paper you're going to appear for. If you like the video, don't forget to click the like button, share the video with your friends, subscribe to my YouTube channel if not done so far. Keep watching, keep practicing. See you in the next video.